Hello everyone. So today we're going to start our new unit on systems of equations. This is when you have more than one line on a graph. The cool thing about this is there's a ton of resources online. So if you don't understand after today's video, go and look it up. Google how to do this. Go to Khan Academy and see more videos. But there are a ton of resources. Don't only be limited to my videos. Make sure you're seeking out those resources. Hi, so today we're going to be on the document camera, but we're also going to be on Desmos because today is solving systems by graphing. And we know our graphing calculator, good old Desmos, can certainly help us out with it. So a system of equations is a set of two or more equations using the same variables, like using x and y. Solving systems by graphing. So there's three main ways we're going to learn how to solve systems. The first one's by graphing. This is when you only have two variables. You can solve a system of equations with two variables, x and y, by graphing the equations set equal to y. So this is when they're in slope-intercept form. This is when they're in slope-intercept form, or the y equals mxb form. So you do need to make sure they're equal to y if you are graphing these by hand. So there's three different types of solutions you can get. The first one is when you have a graph that looks like this. And that's going to be a one solution equation. And that's because the one solution is where those two graphs meet, or two lines meet. Solution where lines meet. And that's a one solution. It's that dot right there where those two lines cross. Then you sometimes will have parallel lines. Oh, I should put arrows on my lines. Going back and putting arrows. You could have two parallel lines. And these are going to be parallel lines. Now, if the solution is where the lines meet, where do parallel lines meet? They never meet. So there's no solution. And I might put up here parallel lines. So I remember when there's no solution, it's because they are parallel lines. And remember, there's two things about parallel lines. They have same slope, different y-intercepts. I'm going to put a different b up there so we remember y-intercept means b. And then the last one is when you can have infinite solutions. So all the points count. And that's when the lines land right on top of each other. So there's a line and another line right on top of each other. This is two lines. They're right on top of each other. And that's when you get m the same and b is the same. So both the slope and y-intercept are the same in each equation. That's when you have infinite solutions. So let's get into solving a system of equations by graphing. So what is the solution of this system of equations? You use a graph. So I'm going to show you how to do it by hand because sometimes this is going to be in a calculator inactive section. But then we're going to go to Desmos and really see how simple it is once you use Desmos. So first up, if I'm graphing this first equation, the y-intercept is 2. So I'm going to put a dot on 2 on the y-axis. And then the slope is 1 because there's nothing in front of x. We assume it's 1. So I'm going to go up 1 over 1. Up 1 over 1. And once I have a couple points, I can draw my line. Now this is where you do need to be a little bit more exact with how your line is. So if you want to do more points, you're more than welcome to do more points to ensure your line is nice and straight and goes through the right points. All right, now for the second one, my y-intercept is -2, so I'm going to put a dot on -2. And then my slope is 3. So I'm going to go up 3. 1, 2, 3 over 1. And then I'm going to do that again. 1, 2, 3 over 1. I'll keep going. 1, 2, 3 over 1. 1, 2, 3 over 1. I'm going to draw my line. This is where it's really nice to use a straight edge. All right. Now, the point where they intersect, I'm going to do this in a different color, is the solution. And the solution is a point, so we're going to write it as a point. It's this point where they intersect. And they intersect at 2, 4. So the answer is 2, 4. Now the way to double check this is we're going to plug 2 in for x for both of these, and hopefully we get 4 out for the y. So 2 plus 2 is 4. We got the y 4. Plug in 2. 2 times 3 is 6. 6 minus 2 is 4. We got a 4. So that is it. It's where the point is the same and works for both equations. There's only one point where that works. So now let's put this in Desmos and see what happens. So we're going to put this equation into Desmos. Both equations, sorry. So we have y equals x plus 2. And then we have y equals 3x minus 2. And if you see, there is a dot where those two meet, and those two meet at 2, 4. You should also put this into Desmos so you can see that they meet at 2, 4. And that is what we're doing today, was we're just seeing where that meets. We're going to do one more where we're going to graph it ourselves, and then I'm going to do for you real. We're going to use Desmos after that. So let's start here. Our y-intercept is 4, so we're going to start with 4. And then the slope is 2, so we're going to go up 2 over 1, up 2 over 1, up 2 over 1. And if you want to go the other way, you go down 2 to the left 1. And that'll help you know which way to go for that. Because a negative over a negative makes a positive. So if I go down and to the left, that's 2 negatives. I still get my positive slope. All right. So now that we have that, the second equation starts at 2. And then we go up 1 over 1, up 1 over 1, up 1 over 1. Or we could go down 1 to the left 1, down 1 to the left 1. Okay, making sure I graph this correctly. And we have a point of intersection. It's right here. The reason I like to use Desmos is I think it's a little bit better shown, but it's okay to do it with a graph as well. Sometimes you have to. So this point is -2, 0, because I went 2 to the left and I didn't go up or down. So that's the point. Let's double check that works. So I plug in -2. -2 times 2 is 4. Or sorry, -2 times 2 is -4. -4 plus 4 is 0. -2 plus 2 is 0. All right, let's double check this in Desmos right now. So we put this in Desmos, and I get y equals 2x plus 4, and y equals x plus 2. And if we look at the point of intersection, it's right there at -2, 0. All right, for the next one, we're going to do this whole one in Desmos because it's very easy to do it in Desmos when it's not solved for y. So you can do the whole thing in Desmos. Let's look at what this looks like. So we have 2y minus x equals 2. And then we also have y equals 1/2 x plus 1. And as you guys can see, I only have one line on here. If I turn off the purple line, I can see the green line. There's only one line on here. So what happens when there's only one line? Remember from the top, that's when you have infinite solutions. Let's graph this really quickly. I'm just going to use points from Desmos. So one of the points is 0, 1, and another point is -2, 0. I'm going to put a rough sketch in there, and we're good. As long as you plot 2 points, you are good. All right, we're going to do the next one in Desmos as well. We had infinite solutions for that one. Let's see what happens to the next one. Just so you know, the slopes are the same, but the y-intercepts are different. So we should know what should happen. Let's see if that actually happens. Y equals 2x plus 2, and y equals 2x minus 1. As you can see, we have 2 parallel lines. And if we have 2 parallel lines, we have a no solution system. So I'm going to plot these 2 parallel lines real quick. Again, especially when you're using Desmos, this does not need to be exact. You just need to know that they're parallel lines and have a couple points to corroborate. All right. So we're going to look at the break-even word problems right now. So looking at these break-even word problems. One satellite, sorry, I need to go back to that screen for you. One satellite radio service charges $10 per, remember what per means, that means we found our slope, plus an activation fee, that's like an initial fee of $20. A second service charges $11 per, another slope, month plus an activation fee of $15. For what number of months is the cost of either service the same? So we're trying to find the solution. Let's make sure we write our equations. So the first one is y equals 10x plus 20. The second one is y equals 11x, because the slope is 11 here, plus 15. So now that we have those two, we can put them into Desmos. So we have y equals 10x plus 20, and the slopes aren't the same, so we know it's going to be at least one solution, and y equals 11x plus 15. The dogs wanted to say hi. And if we zoom out, we're not actually graphing here, but we are using our graphing tools to graph here. Maybe I have to zoom out a little bit more. Here's the point of intersection. It is 570. So this is the point 570. Now we got to answer the question. For what number of months is the cost of either service the same? We need to know months. And months is time, and time is always X. So if we need to know months, and months is X, it is 5 months. And at 5 months, the cost is $70. Another way to remember that is the slope is money per month. And we know slope is y over x. Okay, let's look at the second one. At Comerica Ballpark, the Detroit Tigers charge $5 for each ticket. When you see the word each, that is going to mean slope as well. And expect to make $1,400 in concessions. So that's going to be an added amount. That's going to be your y-intercept, because it's an added amount that they expect to take. The dogs need to go to the bathroom. They can wait 2 more questions. The team must pay its players $2,000 and pay all other workers $1,600. Each fan gets a free bat that costs the team $3 per bat. How much must be sold to break even? So the first equation is very simple. It's y equals 5 for each ticket, x plus $1,400 in concessions. Now the second equation, they make $3 per bet, 3x plus how much they have to pay the players and workers. So $2,000 plus $1,600, that's how much they pay their employees, gives me $3,600 if we add them. So that's how much the employees are paid, plus $3 per bet. Now we have 2 equations. We are going to make sure we put these equations in. Y equals 5x plus 1,400. And then y equals 3x plus 3,600. And as we do this, I'm zooming out some. And I see this is the point right here. It is 1,100 and 6,900. That's my point. And it says, how many tickets must be sold to break even? How many tickets must be sold to break even? Now, tickets are up here, and it's money per ticket. So y over x, so x is your ticket. So it's 1,100, because this is x, y, 1,100 tickets. Nice, one more problem. We got this, guys. Mr. McDowell invested $14,000 in equipment to print yearbooks for Audrey Kell High School. So that's like a base amount. Each yearbook costs $7 to print and sells for $35. How many yearbooks must he sell before he breaks even. So it's $7 to print per yearbook. So money per yearbook is our slope. And it's $7 per yearbook plus the amount of money he added on in equipment to print the yearbooks. So $7 per yearbook to print them plus the additional $14,000. Sorry, not $1,400. And then they sell for $35 per yearbook. Now, there's no additional fee they get for selling ads or anything. It's just $35 per yearbook. So we're going to put these equations in. And we get y equals 7x plus 14,000 and y equals 35x. If we zoom out a little bit more, I see my point is right here. 500, 17,500. Now, how many yearbooks must he sell before he breaks even? He breaks even when these two equations are the same. That's why we're trying to find the solution. And I need to know yearbooks. So this is y over x, y over x. So x is our yearbooks. And he would need to sell 500 yearbooks. So let's double check this one just to make sure. If we plug 500 in for x, let's see. If I say that x equals 500, I'll actually just plug it in. So I have 7 times 500 plus 14,000. I get that it costs $17,500 to make 500 yearbooks. And then if we're looking at the profit one, that's 35 times 500. They make $17,500 when they sell 500 yearbooks. So that evens out. They break even. And that's what it means to break even. Okay. So your activity today, I'm going to make sure I know what it is before I send you off on your way. Your activity for today is not up here. Sorry. Your activity for today is to do the lesson check. That's what I thought. I wanted to make sure. So the lesson check at the end of this is your activity today. So you have 1, 2, 3, 4, 5 questions. And you are going to submit these 5 questions. You can either take a picture and submit it, whatever works best for you. But you need to do these. You can sketch these graphs. They don't have to be exact. Don't worry if you can't print out this paper. Sketch the graphs. You guys got this. The assignment is linked. I hope you guys have a wonderful day. You guys, I'm just so impressed with everything that you've been doing. So keep it up.